Assalamu alaikum, everyone. Welcome to our session today for the free workshop for the oil field management OFM software webinar. Uh, this is Abdullah from Reservoir Solutions Company. Just we will start by 5 minutes presentation about Reservoir Solutions, and also we will introduce our instructor for our webinar today. For Reservoir Solutions, Reservoir Solutions is a company specialized in providing technical studies and courses for oil and gas companies and professionals. The company incorporates many professionals with diverse technical background related to oil and gas exploration and production. Our services include technical reservoir studies, field development planning, reservoir static and dynamic modeling, economic feasibility studies, technical support for academic researches, PhD, and master degrees. Also, we are assisting in writing technical papers and publishing. We are providing technical petroleum courses by industry expertise, and we are providing mentorship programs. For the upcoming events that we are having into or during this month, we have upcoming workshop that will start at the middle of this month, which will be for petroleum economics. In this workshop, we will have about 5 sessions in which we will learn the fundamental and also the advanced analysis associated with feasibility studies for the petroleum projects. Okay, so for the details for this workshop, we will send it into the Zoom chat. Also, we have another workshop that will be into the 1st of July, which will be for integrated production modeling, IPM. We will introduce how to model the well, how to model a reservoir, how to model a production facilities, then engage all these models in one model to predict the performance for your field. Also, for the detailed for this workshop, it will be sent into the Zoom chat. About our today event, the instructor for our today event is Engineer Muhammad Al-Jawhar. Engineer Muhammad Al-Jawhar joined Basra Oil Company in 2021 as petroleum engineer into the BVT lab. Since then, he has built up a broad range of oil field experience over 15 years. In 2010, he joined Humaila Operating Organization as petroleum engineer, managing producer wells and all related production operations and completion design, production optimization, including planning, executing, and supervising high-profile downhole completion, wellbore interventions, reservoir performance monitoring, production logging, well integrity, which includes pipe, cement evaluation, artificial lift techniques. He have hands-on experience with industry standard software packages like OFM, Prosper, CAB, IVM. Engineer Muhammad has a high experience in oil and gas production technology, completions, intervention, stimulation, abandonments, well testing, nodal analysis, perforating and development, and application of new technologies onshore in desert fields. For our webinar rules, please, if you have any questions, you can drop it into the Zoom chat, mute your microphone and camera, fill into the form that will be sent into the Zoom chat in case that you want to have a certificate for attendance. You can join our Telegram channel for upcoming webinars and courses, and this link will be sent into the Zoom chat. So thank you all, and Engineer Muhammad, you can start. You can start now, and you can share your presentation.
Thank you very much, Abdulrahman. Hello, everyone, and good day for everyone. Thank you all for joining us today in this workshop. It will last for 45 minutes, hopefully. Our workshop will talk about oil field management using one of the powerful software from Schlumberger, OFM, Oil Field Manager. So So the outline of this presentation or this workshop to introduce you to the oil field management, and I will give some examples from the OFM database and the real life field examples from the OFM and digital oil field, and how is that connected to the OFM, and then we have open discussion. I will spare that because they already introduced us, Mr. Abdullah. Thank you very much. So our workshop objectives is to learn about some simple principles in managing oil and gas production companies with complex and intensive data processing. You know, everyone, the most important part in our industry is the data. And this data, how we collected it and how we analyze it. This is the very important part, because if you don't have the relevant data, you don't have the relevant decision. So this the most important part I will discuss some later on about this part of the data and how we can manage it and how we can get most of it as to make it good decisions to be profitable under changing trends, policies, and guidelines. So you have to ensure for the proper management of the oil production and operations, we have a good data again. So oil and gas industry contributes to economic. You know, everyone, how much the oil and gas industry contribute to our economic. And it's one of the important sectors, as you know. Most of the rich countries, they have oil and gas industry, and they have successful industry in this. So it's this engineering technology advances which interest the engineers at large, because this is you have multiple sections in oil industry, so they have a couple of, let's say, thousands of engineers working there around the globe. So this is the risk to be implemented and supported to look into the effective way of managing oil and gas projects. So how we can manage our oil field. This is we are going to discuss and share the knowledge about using one of the most important softwares, OFM. So oil field management, how you can start and finish this project. You know, managing projects, especially in oil field, is very important. So you have to know the main phases in this any project in the oil field. So we will ask, what are these phases? So let's start from the 0 point to the end. So what is the 0 point in any project field life cycle? To what we call field life cycle. So it's starting from explore and then appraise what we have and develop about what we got from the start point of exploring what the fields have, and then we produce that our project and our fields. So these phases, it's connected to each other and connected to each other. So without exploring appraisal stages, we don't have the good develop and produce stages. Oil field management, or OFM, or field manager. So it's a powerful suite of models developed by Schlumberger Information Solution. And this OFM and this design program, it's designed to aid day-to-day surveillance and management of oil and gas fields. So, you know, as I mentioned before, the data you have and the data you've got from your wells, this will help you every day in surveillance and managing your wells effectively. This OFM provides an intuitive, user-friendly interface enabling you to view, enhance, and analyze production and reservoir data. Using this OFM, perform basic or complex analysis for individual or multiple completions, group of wells. So you can check each well, or you can check the whole field. I will show you the main screen of the OFM software in a minute. So this is one of the major important component of OFM software. It's ideally suited for the occasional user, sophisticated enough for the experienced geoscience or petrophysicist, whether it's the well site, office, or home, even the petroleum engineers, reservoir engineers. So OFM, as a mark of Schlumberger, it's a production surveillance and analysis for oil and gas properties worldwide. So integrated tool, it's a good integrated tool for what? Linking dynamic data, as we can get a dynamic data, real life data, or static, domain-specific workflows, a well, reservoir, and field surveillance, and production performance. This is what we are going to focusing on today in our workshop. We'll talk about how we can get benefit from this OFM software in terms of surveillance and production performance analysis, because you have a couple of wells, let's say 10, 20, 50, 100, even thousands of wells. So you have to know how you can get the whole picture for the oil field, and how you can get the whole picture of your well. So how you can manage the whole field and how you can manage the individual wells. So we are going to discuss and see how this software can help us in terms of making a good surveillance plans and production performance analysis. The other tool in OFM is the forecasting and reserve estimation and depletion planning, performance benchmarking, candidate recognition, mapping and trend analysis, water flooding optimization and pattern analysis, enhanced oil recovery, project management. So again, the OFM database is very essential and important. Let me show you. So the key here, you have to see what you have to put in your database as a database to your software. So the key database in terms of concepts, there is a primary keys and there is a records for each tables. You have to put the relevant data for your wellbore and the XY in your field, because if you don't have these relevant data, so in the OFM, this is the main screen of the software. So you can see those wells located in the field. It's regarding, you have the XY, the correct XY of each well in this field. You can recognize where is located, and the other part, you have to know what is the main connection between them and how you can manage the production and surveillance strategies regarding their places. So I will discuss in a minute how we can get benefit of this. And this is the most important thing you have to know, and you put in your mind the tables you are created. So each table is connected to another. So should be a master key, and these keys, it's unique because there's a good example of each well has its unique position and unique ID. So it should be connected to other tables because you have a couple of data regarding surveillance and logging and the production, well tests. Every surveillance you have to conduct to each well should have a table and those tables should be connected to the master table, and those master tables connected to each well in the program. So this is a couple of tables and in the database inside the OFM. So as again, there is a whirlpool ID and completion ID and the date and what is going on in terms of oil and gas and water regarding each well. So those database is what will be put it inside the program, and you have to know the location, the completion, initial pressure, porosity, perforation, etc., total depth, all these kinds of data will be put inside the software. Why? Because we have, let's give you a brief example, a brief explanation about the software. So we have a base map, starting with the base map. This base map have all the wells inside our field, and we have a completions. So these completions is related to each well. So we have each well inside the field, and we have main analysis in that software. I don't know how to. So yes, okay. So yeah. So we have a couple of tools, handy tools, to using this software, from plots, reports, forecasts, grid map, bubble map.
Engineer Muhammad,
yes.
Sorry for this interruption. Actually, we are seeing now the presentation, not the software.
Oh, sorry.
Okay, so.
So I have to change from screen to screen, right?
Yes.
Okay.
Okay.
My apologies.
No problem.
So again, this is the main screen of the software, the OFM software. So in this main screen, you have the analysis part, the properties part. These properties regarding the grid map and the wells, the completions in the other side. And you have these filters. So in this main screen, we have a good example of what we have in the field. So we can enlarge some part if we want to focus on those things, on those wells regarding the surveillance or production performance. So let's back to the data. Sorry. You can see this now?
We are seeing now that.
Okay. So this static data contains data that does not vary through time. So this is the static data we have. With this data, you have the location data. So the location of the well, the completion date, initial pressure, as I have said that, total depth, perforation, porosity. So these examples of what we have and we have to put inside our software. So whirlpool ID, completion ID. So all these kind of tables we have to put. I want just to show you, we will not focusing on the data itself, because the data it's related to the data management, and data management will prepare all these kinds of data and put it inside the software. But just to give you an example how this data was prepared and what is the structure of this data. For example, this is the daily. As a daily, there is a tables. It's called daily, and these daily will have the oil, gas, water, pressure, upstream pressure, downstream pressure. I will see it in a minute in the software itself. And there is a monthly, because there is a monthly production of oil, monthly production of water, monthly production of gas, the cumulative, etc. So all these have tables inside the OFM, inside the database of OFM. So these data were created and will maintained by the data management sections and have to put exactly as it is and reviewed, and because it's very important when you have relevant data inside your the software. Otherwise, you will have a bad decision because every well is connected to another in some way, and you know the reservoir properties and the channels, etc., the formations. So if you don't have the relevant data, the well, it's not in the right location, so you will have a bad decisions and will disrupt your reservoir. So, for example, the pattern, how you can manage the, for example, the water injection. So it's a pattern have to be set correctly according to the wells inside the field. So this is the layout. This is the not fixed layout for OFM database because each company has its own database. So they fix it and put it as they would wish to see in the software. So every company has its own data management section, and this data management, they will think what we would like to see in the main screen of the software. We have calculated variables inside the OFM. So what is the calculated variables? Calculated variables, it's used to have extra calculation inside the software. What I mean by extra calculation, so you have to put your own formula inside the software, and would like to see what is going on in terms of production rates, gas rate, water rate for the specific wells or the whole field. So you have to put your calculated values inside this using this software. So this is the example. So complete name, fluid type, oil, water, gas, and calculation type, and frequency. Is it daily? Is it monthly? So what is the term of the calculation? Is it a test done for the specific well? So for the production fluids, we have oil, and what is the oil? It's described in front of it: condensate, LPG, water, produced water regards a well type, gas from the gas well. So everything it need to be defined in the main description of these tables, and you know, because of it, you will exactly know what's going on in your software, because otherwise we'll be lost inside the data you have. So injection water injected during water flooding, because you have to know what is the injection fluids. If you have water injection, gas injection, or gas lift, it depends what you have in the real life of the field. What is the main description of the field, and what is the main what is the type of injection fluids inside it. So there is another table describing this injection fluids. It's gas, okay, but it's CO2 or polymer, solvent, steam. So all this description has to be explained correctly and accurately inside the tables. So again, in terms of fluid type plus calculation time and frequency. So for monthly, you have to put your, what is the monthly exactly? It's volume measured monthly, cumulative monthly volume, first month, and this is the first month, and or the yearly. It's will be used by the often software to predict the production forecast using a production forecast. and what is going on in terms of cumulative production. So all these data, it's going under the data frequency, and this is the monthly calculation. Again, every company has its own calculated type. So you will see maybe in another company there is another different name for those type of calculation. But however, it's all related to the monthly calculation, and the description has to be defined correctly for each name of it, because you are going to use it. So you have to know what exactly you are using. So for the daily basis, again, fluid type, if it's water, gas, or oil, and what is the calculation type, at what is the frequency. We have daily and we have sporadic. So sporadic for the test, and if you have a test on each well, on individual wells. So daily volume measured daily, and well ID, cumulative daily volume, first day. So it's again the same name, types almost, but the data frequency is different. Let's back to our sorry. Okay. So OFM has a definition for each well. So, and another definitions came from the data management. So you have to know what's each name, it's put it there because you are going to use it in your daily basis. So if there's a difference in the names, should be there's a comments in against it, and what is this shortcuts, and what is this status, well status names regarding to what. So it's very important to know each one, because the generated tables, which will be all put in database, this access database, and it's called workspace. It will be inside your software, and it will be again using inside the software. So just a minute. Okay. So again, so this is the main database, main base map. So every single step you have done, you will see it in the analysis pane. For example, if you want to plot
Engineer Muhammad? Okay, so sorry for all. I will contact the instructor because I think that is a network issue.
I'm sorry for that. I think I lost the connection.
Okay, no problems here, no problems. Engineer Muhammad, if you can close the camera, it will be better for the connection.
I'm terribly sorry for
No problems here. So if you can close the camera, it will be better for the connection.
Stable. I hope you have. I'm terribly sorry. I don't know why today is
No
the
problems here. Just close the camera. It will be better.
I turned off the camera,
Okay, great, great. Thank you.
but still this and not stable.
Okay, it's now good. It is now better.
Okay. Okay, no problem. So let's take this example of the water and the daily report of water cut and the production. What I mean previously about the relevant data, you can see from this example, there is a scatter plot here, couple of points of production, and then there is a continuous lines of production of oil production, water cuts, and water production for the well. So this is one of the relevant data you should have. Otherwise, there's a big uncertainty what's going on in this period. So after this, starting from this time, and you can zoom it a little bit to see a good graphs, good lines of the well, what is doing in terms of performance. So in the previous illustration, we see a couple of points. Those points, it's hard to distinguish what is going on in terms of production, what the well is doing. So the relevant data and the collection of the collective of data and have to put it inside the OFM is very important. That's why I'm mentioning the data management should focusing first on the data and what we have to put in terms of daily, monthly, yearly production in terms of water, gas, etc. And if it's related to the well and it is continuous, otherwise we cannot give a good example of how to manage our wells. So you can see from this well, for example, for instance, there's a couple of declining in water rate, water cut, and the water rate and production rate. So it could be we have a stop period here, we have a test, we have we shut in the well for a specific reason, and then back again to the production with a stable water cut, but with increase in production. So regarding the data, previously we don't have a good decision how to take a good decision if we don't have a relevant data. Here we can see the well was doing very good, and suddenly we lost the well for some reason and struggling back to the production, but again we have a stable condition and performance for the well. And then we have another decline, but that's related to raised water cut. So if you don't have a good data, so you don't have a good decision. So this is one of the things. This is another example when we have a good production rate, and when we do something here, the well is still producing, but we increased the production rate. This is maybe regarding the petroleum engineers' decision to optimize the well production. We gain extra oil, but suddenly the water cut, it's raised, and we have a higher rate of water cuts production. So these things will give you a good indicate how you manage the well in a good manner, a good way, because you have a good you have a relevant data from the well cycle, the life of the field, and you can draw another one. So this is for the whole field in terms of the daily production. So the OFM has a good presentative photos of and graphs of the production. And again, let's back to the bubble map, for instance. So we have here this bubble map. It's related to time, so you can see if you move it, you're in terms of time, to see what is going on in terms of production of the water cut related to each station in your field. So you will have a good decision on how to manage the water cut in that specific location. So this is another one, another bubble map plot. So each bubble is related to, you have to put it as I mentioned before, the calculated bubble. Each bubble, what it's represented to. So the red one, it's the higher water cut. The blue one is the lower water cut. So from the snapshot of this illustration, so you'll see where you have higher water cut wells, and those water cut wells, is it connected to the next wells or not? Is there any injection pattern here, water injection? Do you have water injection or not? So, well, a good connection with the reservoir engineers and petroleum engineers, you will have a good reservoir field decision how to manage all those high water cut wells. If you need intervention in terms of water shutoff or not, and if you have to put a backer, if you have to put another formation and shut in this formation because it's maybe connected, and those water injection wells just close to the producer one, and there's a water breakthrough from those wells. Maybe you have to investigate if you have a bad cement or a leak in casing. So these kind of questions the petroleum engineer and reservoir engineer can ask regarding these kind of data. You have it from your software. So again, the data you have, the relevant data you have, a good decision you will get. So all the base map, when you have it correctly inside your software, so you will know exactly how that can be managed, and how the connection between the wells, what is the connection between the layers inside the field, and how you can manage the injection profile inside your field, and how you can manage the water cut in the later part of the live field. So one of the things you can manage inside this software is changing status. For example, if you have a gas producer or oil producer and convert it to another things, you have to change it. And when you have to change it, you will know exactly there's a change inside the OFM and the screen, and have a new legend next to it, and you can see every status change. So for example, if you abandon a well and what it's the well status is to be changed, and the status, the online status is online or offline. So each kind of each you have to put, you have to put it correctly, and you have to consider why you have put it and where you have to put it, and how you can manage it. So the legend will show you exactly where it's located, those wells, and what after you changing the status of it. One of the, as I mentioned, one of the major things you have to check, and you can see inside your OFM, it's the graphs, the plots. So for example, the cumulative production in the reservoir, and the reservoir pressure, and the produced water. So this is a big picture of our field. So you can see from this illustration how the reservoir pressure was, and how it's going on here, and why it's going up a little bit over there. So from this station, there is a high water cut here and a high water cut here, and there's water here. So it's look like there is a production is cutting, and good production, and this good production, it's declining the pressure, and have a good water injection profile, and then have the raise again in production. However, it's unfortunately we have raising in water cut as well in the oil field. So all these indicates how we can manage the oil field, how is the production profile in our field is going on, and what in terms of the real data we have, and from the static data we have. So all these collected inside the tables of OFM. One of the examples we can see, it's degassing daily production. So from this graph, you can see the daily production in regarding the oil and water and gas. So all these things, you can see how the gas station and how many wells it's connected to the degassing station, what's making this decline happen, the production of the degassing. So you have to investigate, because it's something related to one well, two wells. So it's related to all wells connected to the degassing, or specific wells with high profile of production performance. It's affecting the degassing production. So this one on powerful tools we have in OFM, the plots, and this is plots should be connected to the relevant data again. Back again to the bubble map. So this is the cumulative oil production and water injection. So from this illustration, you can see those contributor to the water injection, and how those wells to the producer one, and what is the effect of your injection. Is this injection profile is good enough? There's another factor playing here in terms of the connectivity between the layers, and if maybe there's a fault making there's no connection, and you injecting in your field with no benefits. So is that will have a good connection? Is it there's a good connection between them, or it's the same profile for all well producer well, and the injector well is going to another place? So these one, for example, for instance, why this not having a good injection? Is there any skin? There's any problem with this well? We need to make extra investigation on how to manage the injection profile for this well. Why this well is not doing well? Is there any term of asphaltene or something like that on any making the well it's not doing good? So all these kind of questions can see from this software, and this is the most important things you can see from this software. Another one, the monthly and cumulative oil production again. So this is the not for the degassing, it's the well production performance. So as a monthly production, you can see there's peaks, and there's a period of not producing, and again there's a peaks, and etc. So why those happens, and what is the main factor played here to make this production related to this? So now here you can see it's almost 10,000, and we have here around 3,000. So why we lost so much production from this well? It's from 2000 and nearly to 2008, 2009. So the time difference around 8 years. And what is going on in those 8 years, in spite of these shortened period for 2 or 3 years, and why it's shortening and why it's back again? We need to yes, and this regarding we have a restored production from the well around 13 or 14 MBD. So from 3 to 14, we have the well logs, the previous data, and we know from 2007 to 2010, around 3 years with a stable production, but it's almost 3 MBD. And again, the well produced more with around 15 MBD. Why we have this doubled, more than doubled production rate from this well? So this is the things, if we don't have relevant data and we don't have relevant good decision, so and a good discussion about what is going on related to this well, and why the well before was doing very well. It's reached here about 24 MBD in 1988, and going down to 3 MBD. And so it could be there's a profile of pressure going down, I mean reservoir pressure, or something related to the well itself. So after managing it properly, we have extra oil, 10 MBD almost plus from this well. So it's good example to manage the our wells, and manage the data and have a good decision regarding the well intervention campaign, what we have to do for each well and what we have to do for the whole field. So again, having said that, this is the monthly production, and we have to focus. We can focus on what's for time being period, and how we can manage it effectively. So from the live field example from the OFM, what I mean by real life field example, real life mean it's the real data. It's coming from the reservoir, from the degassing, from the wells. So if the OFM can be connected to the real life SCADA system, and we can have a very good example of the relevant data from it. So for example, for instance, we have annulus and tubing pressures, and we have the annulus and tubing flow. For this one, it's the water cut, choke size, sorry. And this is the tubing flow, annulus flow, and tubing annulus flow, and the pressures. So if we have this section, you can see there's a we closed the well, and the well was opened tubing annulus or annulus only, and we have rise in pressure. Then there's a open choke, and there's a change in the flow path, and the well is stable. So these kind of things, if you have it and you have a good decision, you can manage the well performance very well, and you can have a good stable pressures for long period. This means the long performance of production with the stable performance for each well. Then we have, as a whole, you have a good performance for the field. This is another example of the real data from the field, and you can see here a bad example of playing with the well. So this is the choke. It's opened, closed, open, closed, and open, closed. So in this period of from the well performance, you can see the petroleum engineer have a bad decisions, and these bad decisions regarding the he's open, close the flow path, changing the flow path, and that's related how to the upstream and downstream pressures, and you have unstable well. So this unstable wells will not give you a stable condition of well performance. So even if you have the data, you should have a good decision. Why he's doing that? This is the question. Because if we back to this illustration, you see you have all the points away long, right? So the choke, the flow path, and the pressure for the upstream downstream. But you have here in this illustration, for this well specifically, there's playing around with the choke, trying to manage the well performance. However, there is a long period, because from this point to this point, he changed the flow path for tubing, and then changing to annulus, back again to tubing, and changing the choke, trying to get and match the best performance for the well. And because here you don't have any data. So you can see from January to May, you don't have any data. So maybe the well from that time to this time, you don't have any data. And this is why the petroleum engineer trying here to manage the well performance, but he afterwards managed it well, and the well goes relatively stable. So there's a stable choke, stable flow path, almost stable pressures. Another example of a good managing the well performance, and you can see there's a water cut here, and it's decreased a little bit because the well is doing good and good managed. So all these examples of the field from you can manage it right away by the OFM software, and this is the most important part. It's how to conduct a surveillance campaign afterwards. So you can, if you have a problem with the well, it's not doing good, and you tried your best with the simple way, and you have to put in your mind to back to your well logs, well tests, etc. What you have in terms of surveillance campaign and what to do afterwards in terms of interventions to have a good performance for the wells. Another one for the field monitoring non-rig activity inside the OFM. So you have a well tests. Those well tests, you can manage the allocated production rate for each well or for the field, because you have, you know, the well test, what's the real data from the test of each well or the whole wells. So how is that compared to those data, to this data, and is it compatible or not? If there is difference, so I have to put in your mind why it's different, why it's the test rate is not as the data you have. So you have to put in your mind, you have to adjust your models, adjust the well performance, and matching the well test data to the exact well what is doing, and then you have a good indication of the PI of each well on your reservoir. This one, it can be managed through the digital oil field. You know, the digital oil field giving you the real data and real life data. So each well has its own data and connected from by the OFM and see the trends. So all disconnected to the well performance and the well models, and then you can see how the well is doing through this data, and how you can manage any usable data and way of the well performance not managed very well. So and how these sudden things can happen, and how you can afterwards put it in a stable manner. So this kind of the data is very important to be reviewed. So this is the end of our workshop, and hope you are getting some benefits from it, and thank you very much.
Thank you, Engineer Muhammad, for your time exerting and showing us these examples during the session. I think that session was very interesting, especially at the end part of the interpretation of the production data. So now it's time for asking questions. So is there anyone that having any question related to our session today?
I'm sorry to going fast and the irrelevant internet connection, but I had the main thing is to give you handful information, how you can measure the data and how you can use it in terms of surveillance and intervention. So this is very important in the real life, and it's very important because otherwise you will have a lot, as a previous example, you have to play with the well, and then you have maybe you lost those wells because some wells is not good enough to produce, and not there, it's not raw flow, maybe it's gas injection, anyhow. So have a good decision, and this decision came from the petroleum engineers and the discussion with the relevant teams in terms of wells, reservoir team, or data management team. All those teams have to be connected and discussed, and because that's why we have well reviews.
And Muhammad, I think that we lost your.
Sorry. Sorry, I can't hear you, Mr. Abdullah. Mr. Abdullah?
Yes, yes. So I think that we lost your voice into the last part.
I'm terribly sorry. I don't know why it's unstable today.
Okay, no problem at all. Actually, you delivered an interesting session, and I think that all the participants have benefited a lot of information related to the oil field management software, and I think that the session will encourage them to learn more and more about the OFM software and using it into the production data analysis. Actually, we have a question here from Mr. Ali Ahmed. Do you have any tips regarding production allocation in case of all the wells are connected to the separator, and how to find the production share of each well?
Okay, so production allocation, yes, because production allocation, you have, as I mentioned, you have to do a well test, and those kind of tests is very important because each time in the field life, the well performance is changing, and how you can manage these changes if you don't have a great or a real data and most relevant data to the well. So the PI changing, the PWF changing, so you have to do a well test. Those well tests will reallocate the production rate for each well, and then it's related to the degassings.
Okay. Mr. Khaled is asking about how can we load or input existing previous well data into OFM database?
All the data we have, it came from data management. So as a petroleum engineer, if you have to put it, you have to go to the fundamentals PDF of the OFM and see how to manage it. It's not very difficult, but you have to be careful when you put it because it's all connected, because the OFM database, it's access, and there is a queries inside the access. And those queries is connected to each table. There is a connection between each table. If you don't have any idea about the access database, so it's not be easy for you to manage the tables inside the OFM. Otherwise, you don't have a good data inside your software. So you have to ask the specific person, so specialize in the data management, and how he can assist you in putting the right data in the right place.
Okay, thank you. We have another question. Can we manage the oil-water contact development, for example, by introducing RST log?
Unfortunately, this software, the database I have showed, there's inside OFM, you can see, I don't know, let me show you something here. There is a logs. There is a log section, single well log, and when you, so there's no data, unfortunately. So there's a single log and there is another well multi-log section. So you can compare and see in terms of well logs, or comparing to the other well logs, where is the oil water contact and what is the movement of the water inside the field and inside your reservoirs, and how you can manage it in terms of well intervention campaign you have to prepare for. So if you have a water injection profile inside your field, and you know there is a water cut rates in some of your wells, as we see from the bubble map. So these wells is cutting water inside the field, and this water raised rapidly from let's say from 1 to 30 to 35, and you have another water injection. So there must be a connection. So you have to manage it quickly but effectively, because otherwise you will have more water inside your degassings.
Okay, so we have the last question. What will one have in mind before starting to use the software?
Say it again, please.
Okay. What will one have in mind before starting to use the software?
What?
Another meaning,
okay, I understand now. So what you have to put in your mind, you have a great software for managing the field. Because if you have to look here, you have plots and you have logs and you have surface map and you have contour map, all these kind of data. If you have it already in your hand, so the first thing in your mind, you should have a data, as I mentioned. And first things put in the slides is the data. If you don't have data, so the software, it's piece of crack, a piece of nothing in front of you. It will not help you at all. So you should have a good data. Otherwise, the software is not going to help you.
Okay, sir. Just the last question. He is asking
No
about
problem.
the definition about voltage replacement.
You have to ask the reservoir engineers about it, because it's a specific question, and you have a discussion, a deep discussion about it. So it's not relevant time we have to discuss like this question, or we'd like to send you in private for some details about it. But I will recommend to discuss it with the reservoir engineers and discuss the void replacement.
Okay, so thank you. Thank you, Mr. Muhammad, for this interesting presentation again, and thanks for your time exerting into this interesting session. Also, I would like to thank all the attendees for their time attending the session. And I would like to remember them that the recording for this session, it will be shared on our LinkedIn page, and also to the WhatsApp groups, and also to the Telegram. And you will find it into our YouTube channel. I will send all the links now to the Zoom chat. Also, I would like to remind them that if you wanted to have a certificate for attendance for this webinar, you can fill into the form that sent into the Zoom chat already. Also, if you would like to enroll to the next upcoming workshops for the petroleum economics and the integrated production modeling, you can also enroll them by the links that will be sent into the Zoom chat now. Okay, so thank you all. Hope you good night. And again, thank you, Mr. Muhammad, for this session, and thank you for the attendance.
Thank you all. Thank you all for attending this workshop. I hope it's get the most of it. There's much more information we can share, but it's the very short time, and I cannot share everything. Just go quickly, and this quickly maybe miss some information. So hopefully in the future we have more specific areas to focus on and get benefits from this software and the oil field management. Thank you very much again, and thank you all for participating in this workshop.
Thank you, Mr. Muhammad. Thank you all. Okay.
Okay.
Thank you. لا انت، لا انت يا ولد، لا.